Welcome to the Explainer. You know, every app on your phone, it feels so simple, right? But underneath that simple interface, it's this incredibly complex machine. So how did the developers actually make sure that machine is built right and built to last? Well, today, we're going to break down structured testing. It's the art of checking software from the inside out. Think about it for a second. When you use an app, you know if it works. You tap a button, something happens, or it doesn't. Simple. But for the people who build it, how do they know why it works? How can they be sure all that code under the surface is solid, efficient, and doesn't have some hidden time bomb waiting to go off? That's the real question we're tackling here. So let's really get into what this means. Structured testing is kind of like popping the hood of a car. It's not just about turning the key and seeing if the car goes forward. No, this is the mechanic getting in there, checking the engine, looking at the wiring, making sure all the internal parts are connected properly. To do this kind of testing, you can't just be a driver. You've got to understand how the machine is actually put together. Okay, so here's our game plan. We're going to start with the basics of what it means to test inside the code. Then, we'll look at 3 methods that get more and more powerful. First, covering every single line, then every choice, and finally, every possible path. And at the end, we'll ask the big question, which one is really the best? Let's get into it. So, you might be asking, why even bother? If it works, right? Well, not exactly. Just getting the right answer for 1 or 2 simple tests isn't good enough. Structured testing is all about building confidence in how the code does what it does. It's about making sure it's tough and it won't just fall apart when it runs into something unexpected. You'll often hear this called white box testing, and that name is perfect because you can metaphorically see right inside the box. It absolutely requires you to know the internal code. You can't do it from the outside. The focus is purely on the structure of the software, and it's usually done at what's called the unit test level. That just means testing the smallest possible pieces of the software one by one. All right, our first stop on this little journey is the most fundamental approach. It's called statement testing. This is really the ground floor for all structure testing, and its goal is beautifully simple. The goal here is, well, it's about as simple as it gets. You have to write a test that makes every single line of code in your program run at least one time. If you think of your program as a building, this is like making sure you've walked into every single room, from the main hall all the way to that little forgotten broom closet in the back. Okay, let's look at a super simple program to see how this plays out. First, the program reads a number, A. Then it reads another number, B. It does a little math. C equals A plus 2 times B. Then it hits a fork in the road. If C is greater than 50, it prints a message. If not, it just stops. Okay, test case number 1. Let's plug in some numbers. We'll say A is 10 and B is 8. The program does its calculation, so C is 10 plus 2 times 8, which gives us 26. So C is 26. The program gets to that decision point and asks, is 26 greater than 50? Well, no, of course not. So it follows the false path and just ends. But hang on. Did you catch that? That final line of code, the one that prints large C, it was never even touched. We completely missed it. Our test has failed to get 100% statement coverage. So, what do? How do we actually hit that last line of code? This is the crucial point. It shows us that one test case is rarely ever enough. If we want to visit every single room in our building, we're probably going to need to take more than one trip. And that question leads us perfectly to the next level up. Decision testing. See, it's not quite enough to just hit every line. Now we have to be more systematic and test every single choice that the program can possibly make. So with decision testing, the goal gets a little more specific. For every single fork in the road, every if statement, we have to make sure we test every possible outcome. We need one test that makes the condition true, and we need another test that makes it false. We have to try both the yes door and the no door. Let's take a really basic check. Is A bigger than B? A single test just won't cut it. We'd need a test where, say, A is 5 and B is 4. That makes the condition true and sends us down the yes path. But then we also need a second test, maybe with A is 4 and B is 5, to trigger the false outcome and go down the no path. Only when we've tested both can we be confident that the decision logic is sound. I really love this way of thinking about it. If statement testing was just about visiting every room in the building, decision testing is about making sure you've gone through every single door, both the entrance and the exit for every room that has a choice. It's just a much more thorough way to inspect the place. All right, now we're getting to the big one. The most comprehensive and honestly, the most challenging method we're going to look at today. If decision testing is about checking every door, then path testing is about walking every single unique route you could possibly take through the entire building. This is the final boss. Here, the goal is to test every single independent journey the code can take, from the very beginning to the very end. We call this a path. It's a unique route through all the logic. And as you're about to see, even in a simple program, the number of possible paths can start to get big fast. To really get this, let's look at a flow that's a bit more complex. This program has two decisions, one right after the other. First, it checks if P plus Q is more than 100. And only if that's true, it makes a second check. Is P itself greater than 100? These two questions create a bunch of different routes through the code. You see what's happening here. Different numbers send us on completely different trips through the code. For path 1, P is 80 and Q is 10. The sum is 90, so we fail that first check right away and we're done. That's one path. For path 2, P is 80 and Q is 70. The sum is 150, so we pass the first check, but then we fail the second one because P isn't over 100. That's a totally different path. And finally, for path 3, P is 110, so we pass both checks. That's a third unique path. Path testing means we have to come up with tests that trigger all of these routes. Okay, so we've covered a lot of ground. We've seen statement, decision, and path testing. They all look inside the code, but they give us very, very different levels of confidence. So let's bring them all together and see how they stack up. Let's just break it down. Statement testing is our baseline. It's good. It makes sure every line gets run. Decision testing is better because it forces us to check both sides of every choice. And then there's path testing, which, in terms of pure thoroughness, is the best. It covers every single logical journey. It's a really clear ladder. Good, better, best. And what's really cool is how these build on each other. Think about it. If you achieve 100% decision coverage, you have, by definition, also covered every statement. And if you somehow manage to achieve 100% path coverage, well, you've automatically covered every decision and every statement along the way. Each level of testing wraps around the one before it, which is why our confidence just keeps growing. Okay, so this brings up a really obvious question, right? If path testing is so clearly the most powerful, the most thorough method we have, why don't we just use it all the time? Why even bother with the other two? And here is the catch. The big but. In that tiny little program we looked at, we had 3 paths. In a real-world piece of software, like a banking app or a video game, the number of decisions is just massive. The number of possible paths can become, well, astronomical. Sometimes, for all practical purposes, it's infinite. Trying to test every single one isn't just hard, it's often flat-out impossible. And so, the real art of great software testing is knowing which level of thoroughness to aim for, balancing that desire for perfect coverage with the reality of time and resources.